In this video, we'll be using the formal definition of limit to determine a delta so that our limit is equal to 29. Here we have the formal definition of limit. It says that the limit as x approaches c of f of x is equal to L. That means that for every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus c, which is less than delta, then the absolute value of f of x minus L is less than epsilon. Our problem that we'll be working on is determine delta so that the absolute value of f of x minus L is less than 0.01 whenever 0 is less than x minus c, which is less than delta. And we're working with the limit as x approaches 5 of x squared plus 4 is 29. We can compare this expression and this expression, and we can see that epsilon is 0.01. And comparing this with our initial problem here, we can see that c is 5 and f of x is x squared plus 4, and L is 29. So let's use these values. In our formal definition, we have absolute value of x minus 5 is less than delta, then absolute value f of x, which is x squared plus 4, minus L, so minus 29, is less than an epsilon, and epsilon is 0.01. So we want to make a connection here between these two. And I'll start with this and simplify it some. Let's combine our constants. We have absolute value of x squared minus 25 is less than 0.01. This is the difference of squares, so I can factor that. X plus 5 and x minus 5 less than 0.01. And now I'm trying to get that to be absolute value of x minus 5. So let's divide both sides by x plus 5. And these will cancel. I'm approaching 5, so this will be a positive value for x. So I don't need to worry about changing the direction of the inequality when I divide by x plus 5 because it's positive. So now I have x minus 5 in absolute value is less than 0.01 divided by x plus 5. So I want to choose delta to be equal to 0.01 divided by x plus 5. Since x is approaching 5, we'll choose x to be the max in the interval from 4 to 6. As we go 1 less than 5 and 1 greater than 5. So the max then would be choose x to be 6. This means then that delta is going to equal 0.01 over 6 plus 5, which makes delta equal to 0.01 over 11, and that is approximately 9.09 times 10 to the negative 4, or 0.0009.